The Avro Canada VZ-9 Avro car was a vertical takeoff and landing aircraft developed by Avro Limited Canada as part of a top-secret military black project carried out in the early years of the Cold War. The Avro car intended to exploit the Coanda effect to provide lift and thrust from a single turbojet rotor blowing its exhaust out the rim of the disc-shaped craft, to provide an anticipated vertical takeoff and landing-like performance and capability. In the air, it would have strongly and deliberately resembled an alien flying saucer. Originally designed as a fighter-like aircraft capable of very high speeds and altitudes, the project was repeatedly scaled back time over time, with the United States Air Force eventually abandoning it. Development was then taken up by the United States Army for a tactical combat aircraft requirement, a sort of high-performance and in-flight testing procedure. However, the Avro car proved to have unresolved thrust and stability problems that limited it to a degraded, low-performance flight envelope. Subsequently, the project was completely cancelled and finally terminated in September 1961. Through the history of the program, the project was referred to by a number of different names. Avro referred to its efforts as Project Y, with individual vehicles known for their particular shape and characteristics, the so-called Spade and Omega vehicles, with the later Project Y2 funded by the United States Air Force, who also referred to it as WS-606A, that is, Weapons Systems 606A, as well, Project 1794, and Project Silverbug. When the United States Army joined the project, it took on its final name of the Avro car and the designation VZ-9, this as part of the United States Army's vertical takeoff and landing capability projects of the VZ series. The Avro car was the ultimate result of a series of blue skies research efforts by Avro's chief special projects designer Jack Frost, who had joined Avro Canada Limited in June 1947 after previously working for several British firms. He had been with de Havilland Aeronautics from 1942, having worked on the Hornet, the Vampire jet fighter and the Swallow aircraft, where he'd been the chief designer on de Havilland's supersonic research project. At Avro Canada, he worked on the Avro CF-100 fighter jet aircraft before creating a research team known as the Special Projects Group, or SPG for short. Frost first surrounded himself with a collection of like-minded maverick engineers, then arranged for a work site. Initially ensconced in the penthouse building, a negatively termed nickname for the executive wing of Avro's administrative building, the SPG subsequently relocated to a structure across from the company headquarters, the Schaefer Building, a secured building with security guards, locked doors and special pass cards. On occasion, the SPG also operated out of the experimental hangar, where it shared space with other esoteric Avro project teams. At the time, Frost was particularly interested in jet engine designs and ways to improve the efficiency of the compressor without sacrificing the simplicity of the turbine engine. He found Sir Frank Whittle, inventor of the highly successful jet engine's reverse flow design, too complex. This led him to consider and design a new type of engine layout, with the flame cants lying directly outside the outer rim of the centrifugal compressor, that is, pointed outwards like the spokes of a bicycle wheel. Power for the compressor was drawn from a new type of turbine similar to a centrifugal fan. The turbine drove the compressor using gearing, rather than a shaft. The resulting engine was arranged in the form of a large disc, which he referred to as a pancake engine. The jet thrust was exited from around the entire rim and circumference of the engine. At the same time, the aircraft industry was becoming increasingly interested in vertical takeoff and landing aircraft, as it was expected that any future European war would start with a nuclear exchange that would destroy most air bases. so aircraft would need to operate from temporary and limited air bases, such as roads or even unprepared fields. Considerable research effort was put into solutions to securing a second strike nuclear capability, and many companies started work on vertical takeoff and landing aircraft, this as an appropriate solution. Frost felt the excellent performance of his new and revolutionary engine would be a natural fit for vertical takeoff and landing aircraft due to its high expected power-to-weight ratio. The problem for Frost and Avro was how to use the annular 360-degree thrust to drive the aircraft forward, as well as the issue of fitting very large powerful jet engines into suitable saucer disc-shaped airframes. As the engine was disc-shaped too, the triangular delta shape was roughly like a spade on a playing card. For this reason his design was also referred to as the Avro Ace, a likely reference to the Ace of Spades. Several other versions of the basic layout were also studied, including the Omega, again named for its distinct Omega character shape and configuration, far more disc-like for its cutaway at the rear portion of the delta wing. For vertical takeoff and landing operations, the saucer-shaped craft was expected to sit pointed up on extended legs. This, however, affected the pilot visibility, as well other issues with similar vertical takeoff and landing aircraft was that stability in a hover was extremely difficult to arrange, although this would not be entirely unexpected from a craft attempting to achieve vertical lift on and cushion of jet thrusts. A good solution to this problem would require a reasonable and decent amount of thrust to be directed downward, and this from a larger area, as it is in a helicopter, where the lift is supplied over the entire area of the rotor's disc. Most designers turned to bleeding off air from the engine's compressor and redirecting that through pipes arranged around the aircraft. Frost's engine design used such a large number of nozzles that this typical kind of arrangement would not be so easy to construct. However, by 1952, his design was deemed advanced enough that the Canadian Defence Research Board funded the effort with a further $400,000 contract. By 1953, a wooden mock-up of Project Y was completed, of which now only images remain. It appeared the project was considered far too costly by some within the military establishment, which was at the time involved in several extremely expensive air defense projects. Therefore, on the 11th of February 1953, a story on the project was deliberately leaked to the Toronto Star newspaper along with images of the Omega design, apparently in order to gain further funding, a strategy widely employed in the US at the time, known as policy by press release. 5 days later, the Minister for Defence Production informed the Canadian House of Commons that Avro was indeed working on a mock-up model of an alien flying saucer as claimed in the press release, and craft, he said, was capable of flying at 1,500 miles per hour or 2,400 kilometers per hour as well, with an astonishing vertical climbing capability. However, despite this crude attempt at blackmailing, having done no harm to Frost or his flying saucer project, unfortunately no further funding was offered. Meanwhile, Project Y continued, with Frost becoming even more interested in the Coanda effect, where fluid flows will follow strongly convex shapes. Frost felt this effect could be used to complement his engine design further to produce a more practical vertical takeoff and landing aircraft, with the exhaust flowing outward over the upper surface of the aircraft, then being directed downward over a flap-like arrangement. This would produce a lift force around the entire edge of the aircraft, allowing it to land and hover a lot more positively and flatly. He produced a number of small experimental designs using compressed air in the place of a jet engine, this in order to safely select a suitable airframe shape. Eventually he decided again that the alien disc saucer shape was indeed the best solution. As the experiments continued, he found the same thrust direction system he intended for vertical takeoff and landing operations worked just as well for forward flight. However, in this case the alien saucer disc shape was not of itself a good lifting surface, as it was neutral in terms of its lift direction. That is, it would fly sideways just as readily as it would fly forward. But by simple modification of the airflow and the application of a small amount of jet thrust, the overall airflow over the craft could be dramatically altered, creating a sort of virtual airfoil that could meet a number of required flight configurations. For instance, by directing even a small amount of jet thrust downwards, a large mass of air would be pulled over the upper surface of the wing to dramatically augment and increase the flow over the wing, creating even more lift for a more pronounced positive vertical takeoff, landing and hovering capability. This appeared to offer a solution to one of the most vexing problems of the era, designing an aircraft that just as effective at subsonic speeds than at supersonic speed. Subsonic lift is created by the airflow around the wing following the wing's characteristic shape and streamlines, but supersonic lift is generated by shock waves at points of critical wing curvature. No single design yet developed could offer high performance suitable for both these regimes. But the blown alien flying saucer-shaped disc could attack this problem by being laid out for supersonic performance only, and then using jet thrust to modify the subsonic airflow into a semblance of normal aircraft wing shape and behaviors. The resulting design would be tuned particularly for its high-speed supersonic capabilities as well as having unreasonable subsonic performance. This would also offer vertical takeoff and landing, and all this in a single saucer-shaped disc design. In late 1953, a group of U.S. defense experts visited Avro, Canada to view the new CF-100 fighter jet. Somewhere along the way, Frost co-opted the tour and rerouted it to the Special Projects area, where he proceeded to show off the Project Y, Frost's flying saucer, a mock-up of models and drawings, some never before seen by senior company officials, for a completely circular disc-shaped aircraft known as Project Y2. The United States Air Force agreed to take over funding for Frost's Special Projects Group, and a contract for $750,000 soon followed in 1955. By 1956, Avro management was interested enough to commit a further $2.5 million to build a private venture prototype, and in March 1957, the Air Force added additional funding. The aircraft then became known as Weapons System 606A. A wide variety of designs were studied for vertical takeoff and landing capable fighter aircraft, all revolved around the distinct alien saucer disc shape, leading to the concept of Project 1794, which involved and proposed supersonic large disc fighter capable aircraft. The concept proceeded to wind-tunnel testing with a variety of scale models. It featured a raised section in the middle over the engine, the intake covered with a series of louvers that would be closed in forward flight. Frost's performance estimates for the concept craft were for a potential at Mach 3.5 at 100,000 feet 30,000 meters altitudes. There was some debate about the Frost concept craft and its distinct UFO characteristics within the United States Air Force, as many competing groups were attempting to gain further funding for their own pet projects, like nuclear-powered bombers. In a repeat of the earlier Toronto Star press release, in 1955 an extensive article appeared in Look magazine that, among other claims, speculated that current alien UFO sightings were in actual fact Soviet-built saucers. The article went on to describe such an aircraft with diagrams that were clearly influenced by Avro's design, and again this could only further Frost and Avro's ambitions and efforts for flying disc-shaped fighter-capable aircraft. For testing purposes, a new engine consisting of 6 Armstrong Siddeley Viper jet engines blowing across the outer rim of an impeller was designed under the name PV-704. The PV-704 was a stopgap design built into a bunker-like building behind the Avro experimental test facility. It was intended to test various Project 1794 concepts and provide the United States Air Force with the necessary test data to show the viability of these alien disk experimental programs. The original plan to initially test the Viper engine rig was to have continued further into free flight testing. Unfortunately, this testing was anything but smooth. The test model suffered from hazardous oil leaks, resulting in 3 fires. It eventually got to the point that staff became afraid of the machine, even when safely ensconced in a booth constructed from bulletproof glass and quarter-inch thick steel plate. A final and disastrous nearly lethal engine test in 1956, which involved the Viper jet engine running wild beyond control, convinced Frost that a less dangerous test vehicle was absolutely necessary. To gather flight data on the basic ideal while his engine development continued, in 1958 Frost proposed building a smaller proof-of-concept test vehicle. He again called this the Avro car. By this point, the United States Army was involved in a wide variety of experiments on smaller vertical takeoff and landing capable aircraft that would act as its flying jeep, and they became very interested in Frost and the Avro car design as well. Frost pitched his smaller design both as a prototype of a vehicle suitable for the Army's needs, as well as an aerodynamic test bed required for the WS-606. Initial performance expectations for the Avro car were a 10-minute hover capability in ground effect and 25-mile 40-kilometer range with a 450 kilograms payload. Frost's new plan for his saucer-shaped flying disc craft appeared to make everybody happy, and a further grant of $2 million through a joint services contract managed by the Air Force was awarded to Avro to build and test 2 new Avro cars, which the Army referred to as the VZ-9 Avro, with the letters AV standing for Avro. As the latest in a series of VZ aircraft, the Army's interest in the Avro car program was said to have been apparently very high. Bernard Lindenbaum of the Air Force Flight Dynamics Laboratory recalls a trip to Washington in the late 1950s to request additional funding for a study on helicopter drag reduction techniques. Although his funding was approved, he overheard an Army general remark that the Huey helicopter would be the last helicopter the Army would buy, since the chopper would be replaced by the Avro car. Additional Air Force funding of approximately $700,000 as unexpended funds from the 606A program was also moved to the Frost Avro car project. In March 1959, an additional $1.77 million contract was received for a second prototype. At the rollout of the Avro vehicle, projected performance was far in excess of the requirement, with a 225 knots 417 kilometers per hour maximum speed, and 10,000 feet 3,000 meters maximum ceiling, and a 130-mile 209-kilometer range with a 450-kilogram payload capability, and an hover out-of-ground effect with a 1,101-kilogram payload. Maximum takeoff weight with transition to forward flight out-of-ground effect was calculated to be 2,560 kilograms. Maximum weight with a transition in ground effect was calculated as 3,160 kilograms. But just as the first working test models of the Frost FO were being manufactured, disaster struck. The Canadian government cancelled the Avro CF-105 Arrow aircraft program on Black Friday, the 20th of February 1959. The ensuing result was the layoff of almost all of Avro Canada's employees, this including those with the Avro Car Special Projects Group. However, 3 days following the announcement of the Arrow cancellation, Many of the special projects employees were hurriedly rehired. But it wasn't quite business as usual. The team now included people from the CF-100 and CF-105 fighter aircraft teams, with the special projects group moved into the main building, which was by now nearly empty. As well, the company's brass became more and more involved in the group's operations. The United States Air Force's project office devoted to the Avro projects recommended that the WS-606A and all related work including the Avro car be cancelled. A stop-go work order came down from the project office and Frost was forced once more to try to rescue his project. In an elaborate effort, Frost made a resounding case for the continuation of US military funding. Late in May 1959, the United States Air Force rescinded on its previous decision and authorized Avro to continue in its mock-up flying disc alien saucer program. The Avro car was a distinct disc-shaped aircraft with the same basic shape as a Frisbee, with more than a striking resemblance to extraterrestrial UFO, something most in government and military circles deny even exist. The upper surface of Avro car disc was fairly curved, and the underside much less so. The disc measured some 18 feet 5.5 meters in diameter and 3.5 feet 1.1 meters thick. The main structural truss and superstructure was a large equilateral triangle to which the various components were attached. The 124-blade turbo rotor motor sat in the center of the triangle, with most of the rotor's jet thrust directed straight down through an opening in the lower surface, though some was bled off to power the control system running along the outer rim of the disc. Power for the rotor was provided by 3 powerful Continental J69 T9 jet engines attached to the truss. Each engine had its own fuel and oil tanks and other support systems, though these would be interconnected in future models. The majority of the airframe was made of aluminum with a dry weight of some 1,400 kilograms. Pilot control was entirely through a single side-mounted control stick. Pitch and roll were controlled through conventional fore-aft and side-to-side motions, while yaw could be controlled by twisting the stick. No mechanical linkages were used. The stick instead controlled the flow of high-pressured air around the craft. The attitude and thrust control system consisted of a large ring situated outside of the main disc, shaped roughly like a rounded triangle with a flat surface on the inside. Viewing the craft from the side, the control flap is almost invisible, appearing in its neutral position to blend into the profile of the saucer-shaped disc. The pilot's controls moved the ring in relation to the rest of the craft, affecting the airflow moving outward from the center of the craft. Vertical lift could be increased by moving the entire ring down, which would produce more airflow over its upper surface, which would then bend down over this surface toward the ground. Tilting the ring resulted in asymmetric thrust for directional control. It was discovered that the craft was inherently and dangerously unstable in forward flight, as the aerodynamic center of pressure was well forward of the center of its gravity. To counter this effect, the Avro car included a mechanical stability control system completely independent of the pilot's inputs. The turbo rotor motor had a fairly large angular momentum and was intended also to act as a powerful gyroscope, providing a normalized direction and stability of flight. Control cables attached to the base of the rotor would be pulled when the craft moved in relation to the rotor, actuating the control surfaces, this in effect to counteract and stabilize the craft's general motion. The vehicle was manned by a crew of 2, positioned in separate cockpits squeezed into empty areas in the airframe. In practice, only one pilot was usually on board during testing, with a number of flights made with an observer in the second cockpit, this until control problems were completely resolved. The Avro test pilots acquired a touch for the extremely sensitive control inputs the inherently unstable craft required, and Avro aircraft chief development test pilot Patoki was eventually able to demonstrate a totally hands-off and free flight. Nonetheless, Avro test pilot Peter Cope and United States Air Force project pilot Walter J. Hodgson, as well as NASA Ames chief test pilot Fred J. Drinkwater, who all flew the Avro car, considered it still a tricky vehicle to fly, this by any standards, with the chief test pilot Drinkwater likening flight in it to balancing on a beach ball. The undercarriage of the Avro car was rudimentary, with 3 small caster wheels mounted on stub shafts. A set of skids was substituted later in testing, although they were not fitted as standard. The first Avro car, number 58-7055, rolled out of the Avro Morton factory in May 1959. From the 9th of June to the 7th of October 1959, it was tested in a static hover rig. Unfortunately, hot gas from the exhaust was found to mix back into the intakes in hover, reducing engine thrust. In addition, the fan generated lift only from a small area of its surface, lowering the overall available thrust capability. The ducts also proved to have higher losses than expected, and a series of modifications were not able to resolve this problem to any greater or lesser degree. These issues reduced maximum lift at higher altitudes beyond and out of the ground effect to some 1,430 kilograms, less than the empty weight of the aircraft at 1,944 kilograms. This meant the aircraft would be incapable of hovering beyond the out-of-the-ground effect. Following these tests, the vehicle was sent to NASA Ames for a wind tunnel testing. The second vehicle, number 59-4975, was completed August 1959. On the 29th of September, the first attempt to hover was made with the Avro car tethered firmly to the ground. After the vehicle became airborne, an uncontrollable roll and pitch-coupled oscillation started that forced each of the 3 wheels into the ground in turn. The test pilot, Patoki, immediately shut down all engines. Changes were made to the stability system again to provide more control rigid authority, while new tethers were investigated in order to improve the ability to control these sorts of problems. However, as the Avro car testing continued, it became clear the issue was inherent to the adopted design, and the engineers coined this peculiar effect as hubcapping, so named as it appeared similar to the motion of an automotive hubcap spun on the ground. Investigations into the effect revealed the cause of this issue. While hovering in the ground effect, the high-pressure air under the craft was trapped, filling the entire area and thus providing a stable base. When the craft rose vertically out of the ground effect, the air formed itself into a single narrow column, described by Frost as tree trunking. At intermediate altitudes, the craft would momentarily transition from one regime to the other, during which time one side of the vehicle would be entirely supported while the support was completely lost under the other. This led to a strong pitching motion towards the unsupported side. As soon as this occurred, that side would approach the ground to re-establish the bed of supporting air, while the other side would then be raised above this limit. This process would repeat itself again and again, with the craft rolling uncontrollably, pitching ludicrously from one side to the other. Modifications were carried out yet again in an attempt to try to resolve the Avro car's myriad of stability and thrust issues. Eventually and somewhat drastically, a series of 52 holes were roughly drilled in the bottom of the vehicle, located radially 3 feet from the center. These were to provide a central jet outlet, this to stabilize the ground cushion. With the modifications complete and apparently working, the first completely free flight occurred on the 12th of November 1959. But on this occasion the test only proved the nozzle control system to be completely unacceptable. The craft's spoilers were intended to direct air out over the top or bottom of the annular flap, out from the underside and only during hovering motions, but over the top and underside of the vehicle during forward flight. The idea was that when the flap was positioned in order to provide control, the lift would be lowered on one side and raised on the other. Lift was indeed lowered on one side, but sadly the achieved lift did not improve on the other, so every control input resulted in a drastic loss of altitude. After 5 flights, testing was temporarily halted on the 5th of December 1959. By that time the Avro car had logged some 18.5 hours of test time in total. Avro car 59-4975 after modifications was tested without the canopies and incorporating the perimeter focusing ring. However, this test only served to show that the heat generated by the powerful onboard jet engines of such a small craft was so oppressive the craft's instruments were baked brown after only a few flights. A completely new design was installed over the winter. The original spoilers were removed and replaced by a single ring below the annular flap. This ring shifted in relation to the craft under control inputs, sealing off the gap on one side while opening it on the other. Tests continued in January 1960 and appeared to work much better. However, while the new control system improved the hovering qualities, the craft now became even more unstable at higher speeds above 30 knots 56 kilometers per hour. The first Avro car at Ames was similarly modified, and, in April 1960, it was wind tunnel tested. The issues dogging the Avro car became clearer. The ring blocked so much of the available engine thrust that the overall power was greatly reduced. As the craft sped up, the airflow on the underside reduced recirculation, in turn reducing the lift due to airflow over the upper surfaces. This was somewhat unexpected. Recirculation had been considered a bad thing due to the loss of engine thrust, and its positive effect on lift do not appear to have been fully appreciated. In the end, in order to maintain lift at higher forward speeds, the craft had to be pitched to the very end of its control capability. However, Avro unmoved despite a catalogue of categoric failures and millions of dollars of taxpayers' grants wasted on its enterprise, too concerned to emulate the capabilities of flying saucers, something everyone denied even existed, as will the engineer's choice. The preoccupation for power from jet engines, radically horizontally mounted to suit the Avro car, such as they were never designed to do. Avro and Frost remained as still convinced their concept was as workable and viable as ever. Therefore they proposed another new program for the major rework of the propulsion and control schematics. Instead of the single annular triangular flap and spoilers, or the later ring control schematics, the new system included 2 separate control systems for hovering and forward flight, combined into a single nozzle. For hovering, a series of transitioning doors were opened into the nozzles, blocking them off and redirecting the jet thrust flow downward under the aircraft. Control during this regime was provided by moving the outer portion of the flap to focus the flow. At higher speeds, the transitioning doors were closed, allowing the air to flow out from the edges of the aircraft, where a series of simple flap-like controls were located. The new control system covered the rear 3/4 of the aircraft's outer circumference. The front section featured the hovering controls only. Modifications were completed on the Ames model and testing resumed in April 1961. The new design demonstrated much better control and hover and considerably improved lift. The vehicle was now able to travel at up to 100 knots, 190 kilometers per hour, a great improvement over the 30 knots, 56 kilometers per hour previously reached. However, it still remained as dangerously unstable in pitch and exhibited a strong nose-up trim. NASA engineers attempted to modify this with a T-tail, but this proved to sit within the airflow of the turbo rotor and did not help. Frost's team considered two new designs, one with a large vertical tail and one with a wing with tip-mounted vertical winglets. Both designs used two 12 kilonewtons thrust General Electric JA85 turbojets and increased the turbo rotor's diameter from 5 to 6 feet. On the 9th of June 1961, a second United States and NASA flight evaluation of the Avro car was conducted on the similarly modified second prototype at the Avro facility. During these tests, the vehicle reached a maximum speed of 20 knots, 37 kilometers per hour, and showed the ability to traverse a ditch 6 feet across and 18 inches, 460 millimeters deep. Flight above the critical altitude proved to be as dangerous, if not nearly impossible, due to the inherent persistent instability of the Avro car design. The final damning flight test report further identified a range of control problems. Therefore, by March 1961, Frost's proposals for even more modified Avro car designs were not accepted, and the Avro car and related WS-606A supersonic programs were officially cancelled, terminated in December 1961 by the US military. Avro company executives still encouraged additional vertical takeoff and landing capable research projects, but no further interest resulted from Canadian or other sources to cap the end of the fund of the Special Projects Group program. In 1961, a number of later proposals, including the Avro P-470 vertical takeoff and landing fighter concept derived from the Special Projects Group, were submitted to fulfill the NATO competition for a tactical strike fighter. These needs were filled by the Hawker Siddeley Harrier, the popular strike aircraft used by the United Kingdom's Royal Air Force, generally known as the Harrier jump jet, whose remarkable vertical takeoff and landing capability ensures its continued success, as will continued service as utilized by many military forces throughout the world. But in more abstract terms, interest in vertical takeoff and landing strike-capable aircraft faded as it became widely believed and accepted a nuclear-first strike would not be used at the start of a European war. The second Avro car had logged about 75 flight hours at the end of the flight testing. Judged by its performance, the Avro car was an abject engineering failure dogged by issues fundamental to its design criteria that, despite much interest and funding, were never ever fully explored. It couldn't lift itself safely more than a few feet off the ground, and its bulbous design limited its high-speed performance, and its accompanied unbearable heat and screaming exhaust noise made it virtually impractical for any possible military use. Although it's somewhat considered a technical failure, its design wouldn't if the engineering issues had been attacked in a sensible, thought-out manner, but it never ever was, and the Avro car was mothballed sensibly, saving the taxpayer a fortune. Though its design dynamics and overall schematics and concept are truly brilliant, its history regrettably is anything but. Nevertheless, company designer John Frost, and not Jack as his name appears in the US Patent Office, incredibly applied for a number of patents in Canada, the UK and the US. This established the pivotal but unfortunate and exhaustive role the Avro car and related Avro experimental vehicles made in the vertical takeoff and landing strike aircraft capable world.